Hello everyone, this is the problem video for 6.3. Instead of doing problems from the book and from the homework, I'm just going to focus on the homework. Obviously, that's probably what you guys are more focused on, and that's probably what needs more help, to be honest. So number one on the homework is pretty straightforward. It's just a factoring problem. And then number two, uh, the factoring techniques are kind of involved a little bit. So number two gives us a picture of a graph. It's one of these parabolas, and it's like a little shaded region on the parabola. And it's telling us to find the volume when we take the region bounded by this curve, and then they don't mention it, but we're supposed to use the x-axis as a bound, right? Our region stops at the x-axis, okay? So they made a little mistake there in not mentioning that. Then we're going to take that region and rotate it around x equals 10. Now, if we factor this equation here, it factors as what, 7x and then 5x minus, or no, 5 minus x. Okay, so that factoring tells us that we have x-intercepts of 0 and 7, okay? And then I'm rotating around the line x equals 10, which would be like that dotted line, okay? So I kind of get a better picture once I factor of what this object's gonna look like, right? So maybe, in the steps I laid out, maybe we would call that step 1. Step 2 would be drawing the three-dimensional object, all right? Okay. So it'd be kind of like a ring, kind of a ring of mountains, right? Like there are these kind of humps here along the barrier, and then there's just empty space in the middle. Okay, so that's kind of what our 3D object looks like. And now let's try and figure out what these approximating cylinders would look like. Okay, so let's say I have one cylinder going through my object. I'll do it in green, actually. I'll just do this real quick. Just hopefully you guys are doing this as well. Okay, so what would the radius of this cylinder would be this distance, okay? What is that distance? Well, let's see. This total distance here from this y-axis to this dotted line, that's 10, right? Because this dotted line is x equals 10, okay? And then if we subtract away this distance, okay, we'll have our radius. What is that distance? Okay, if I have this point on the curve, that distance there is the x-coordinate of that point, right? Okay, so my radius in terms of x should be 10 minus x. Okay, so let's say we got like steps 2 and 3 here. This would be step 4. Step 5, what about the height of my cylinders? Okay, well, again, if this green, let's kind of get rid of this stuff. Boom. Once again, if this green is my cylinder, okay, what's my height of my cylinder? It's that distance. Well, that would be the y-coordinate of that point, right? Okay, it would be the y-coordinate here minus 0, so just the y-coordinate. Okay, and we have the y-coordinate. We need to write that in terms of x, right? Since we've rotated around a vertical line, my guidelines for this cylindrical shells tells me I need to integrate in terms of x. So even though this distance is the y coordinate, I need to write that in terms of x. How do I do that? Well, it's given to me by this equation here. Y equals 35 minus 7x squared. Okay. So my height, which is my y coordinate, can be written in terms of x as 35x minus 7x squared. Okay, and then my bounds of integration, where do I want to integrate? Well, I would only integrate, so for cylindrical shells, I only integrate kind of 1/2 of my object. I kind of integrate from the line I'm rotating around outward, or maybe from the boundary. You know, if I wanted to start integrating here, I would integrate until I reached the line I'm rotating around. Okay. All right, so let's do that. So where do I want to start integrating? Where does my object begin? Okay, my object begins here at x equals 0, right? And then where should I stop integrating? Let's clear this picture up again. Okay. So I start integrating here, and I integrate along my object, but once I hit here, the rest of this is just empty space, right? So I don't need to integrate all the way to 10, and in fact, I shouldn't. I should stop integrating at whatever that point is. Okay, if we had done the factoring, we would see that point is at 5. So I should integrate from 0 to 5. Okay. So now I have all the information I need to form my integral. Okay, so my integral should be 0 to 5, 2 pi, what's my radius? 10 minus x, times my height, which is 35x minus 7x squared. Then I'm integrating in terms of x, so I need a dx. All right, so now let's try and integrate this and see what we get. Okay, so first thing I'm going to do is pull out the 2 pi just so I don't have to worry about that until the end. And then I can multiply these expressions together. Simplify. And once I simplify, I should get this. And then what do I need? Now I can integrate. So I should have this 2 pi times 175x squared minus 35x cubed plus 7 over 4 x to the 4. And I need to evaluate that antiderivative from 0 to 5. Okay, when we plug in our bounds, we should get this. It's, you know, nasty. This homework is, the web assigned homeworks are always kind of gross. So we got 4375 minus 4375, so that those should cancel. And then I should have 7/4 times 625. Okay. So let's try and now simplify 2 pi times 7 over 4, 625. Okay, 7 over 4 times, you know, I got this 2 here, got a 4 here, so that's like 7 over 2 pi times 625. Let's see if that simplifies at all. Yeah, so that doesn't simplify at all. The only thing we can do is actually multiply 7 by 625, and we should get 0.4375 pi over 2. And that's the volume. That would be the final answer. Okay, I'll talk about some more problems. I'm not going to talk about them all, and I probably won't even talk about them completely. But let's look at number 3. I'll talk about the ones that have kind of weird questions as parts of them. So number 3, they ask you explicitly, okay, okay, so 3 is strange because they ask you for the circumference of these cylinders. Okay, so let's look at what I have for 3. We get the curve y equals a sine of bx squared. And then they kind of give us a picture. It looks like this, and they integrate until square root pi over b for some reason. And then they actually tell us a equals 12 and b equals 4. Okay, so they write it like this so that they can, you know, use the same graphs for everybody's problems. And then, you know, for me, they gave a equals 12 and b equals 4, and for you, they might give different values. Okay. So that's what's going on there. So they ask you to sketch one of the typical approximating shells. So all you need to do is kind of picture what this region is going to look like when we rotate it around the, let's see, what are we rotating around? The y-axis? Yep. So picture that 3D region and pick the correct graph. I'll let you guys do that. And then they ask, okay, for one of these cylinders, what is its circumference and height? Okay. So we got to think about, let's see, one of these cylinders. Okay, I won't give in too much in depth, but one of these cylinders, let's see, I don't want to give too much away by drawing the object, but let's say I draw the cylinder kind of superimposed on the 2D region, okay? Half of this, like it would start, maybe I'll do it in green or blue or something. Okay, so I'd start drawing my cylinder, maybe I would draw it to here and then draw it up until I hit my curve, and then it would wrap around like that, right? Okay, so maybe the cylinder would look like that. So what's that circumference? And then remember the cylinder is 3D. Okay, so what's the circumference of this thing? What's the height? Well, how do we find circumference? Circumference is 2 pi times the radius, right? So what is the radius? They're kind of, you know, we got to figure out what the radius is. What is that distance? It's just the x-coordinate of that. It's the x-coordinate of that point is that radius. So if the radius is x, what's the circumference? And I'll let you guys figure that out. And then, okay, what's the height of the cylinder? It's that distance, right? Well, that is going to be the y-coordinate of that point, but we need to write that y-coordinate as a function of x because we want to integrate in terms of x, right? So that'll be my hint for those two, okay? And then once we have that information, we should have enough information to form our integral, right? So the integral always has that formula 2 pi times the radius times the height. And this time we're doing it in terms of x, okay? So it's going to be 0 to something. I'll let you figure out what that upper bound is. And then, you know, what you need to fill in the radius and the height functions. Okay. Number 4 looks pretty straightforward, cylindrical shells. Same thing with number 5. Number 6, I'll just say it tells you to find the volume using 2 different methods. Here's a hint that if you find it by one method, you know, it doesn't matter how you find it, right? The volume is the volume. So you find it by one method, that's going to be the volume for the other method, okay? So there's two answer boxes for number 6. They should have the same value. But finding that value is just again, straightforward cylindrical shells slash disk and washer. Number 7, again, just straightforward. Number 8, same. Number 9, okay, they have something a bit different looking. It's a bit different looking, but it's actually pretty straightforward. Just write out the integral to find your volume as you would with any of the other problems you've done so far, and then just fill in those blanks. It should be pretty apparent what information they're looking for. I will say for part B, they ask you to enter a decimal answer with some rounding. And really, that should be the only time you're entering like an approximate answer. It's like the question will always be phrased like that. Use your calculators to evaluate, blah, 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 and round to 5 decimal places. Okay, that's the only time you should be entering something like that if it explicitly asks for decimal answer. In all other cases, if you get 43 pi over 2 as your answer, that's exactly how you should enter it in WebAssign. You shouldn't plug that into your calculator and round unless they tell you to do that. Okay. Number 10, I would say, is more foreign. So let's look at that. Number 10 is interesting because they give us the integral and we have to kind of work backwards to figure out what that region looks like. So what I'm given in my problem is 2 pi integral 0 to 3 9y over 9 plus y squared dy. And we need to figure out some information about the original region. Okay, so let's try this. So here's how I think about this one. These are kind of tricky and a little ambiguous, I think, but here's how I think about it. So I know these cylindrical shell things are going to have the formula, leave it as a to b for now, 2 pi times integral a to b, radius, and actually let's put these as y since we're integrating in terms of y, radius times height dy. Okay, I don't have it broken down nicely into radius times height, right? I just have this one function up here. So what could be my radius and what could be my height? Well, we've seen in previous problems that a lot of times the radius, well, in almost all cases, the radius is much more simple than the height, right? And sometimes that radius was as simple as y, okay? So let's break this guy up here. Let's break that down into y times 9 over 9 plus y squared, okay? I still have the same integral, right? I've just brought this y over to the left, okay? Well, now it's looking like my radius is y, and let's see, from 0 to 3, and my height is 9 over 9 plus y squared. Okay, so what does my region look like? Okay, if I'm integrating from here to 3, okay, so I'm integrating from 0 to 3. That means my object, this is my object is going to range over this. That's half my object, and then the other half, well, maybe it's maybe it's up here, but actually more likely it's probably down here, right? Okay, so maybe the other half of my object is there. All right, so that means my curve is something like this, okay? And I've rotated it around. Let's see, if I'm integrating in terms of y, I've integrated around a horizontal line, or I've rotated around a horizontal line. So I've probably rotated my curve around the x-axis or some other horizontal line. Okay. Number 10 only gives me a choice of x-axis or y-axis. So it looks like I have some curve Okay, I'm integrating along y, and I've rotated around the x-axis. Okay, what does the rest of my object look like? Well, I know that the height of it is given by this equation here, and it doesn't really matter what it looks like. It's going to be some function of y. It's some curve over here. Okay. Maybe it looks completely different from that, but then my cylinders would be, something like this. Yeah. So that would be maybe one cylinder. Okay. All right. So what are my, and number 10 also asks for bounds on x and y, and that'll be the last two pieces of information it asks for. Well, my y values, okay, okay. Remember, I've rotated around the x-axis, so my original 2D object probably looked something like this. It was some region in the this quadrant up here, and then when we rotate around this x-axis, we got the full 3D picture, right? But my original region is just this stuff up here. Okay. So what are my, for this type of thing, what are my bounds on x and y, right? The problem gives me, okay, x is less than or equal to blank, and y is less than or equal to blank. All right. Well, since I'm integrating in terms of y, okay, my y term is just going to be my bounds of integration. So I integrate up until 3. So y should be less than or equal to 3. What about my x? Where do my x's stop? Well, it depends on where I'm at, right? Because I have this like funky curve, okay? So if I'm looking at this point, it stops in one place. If I'm looking at that point, it stops in another. So how do I express that? Well, x, I should just say x is less than or equal to my function of y. Okay. So that one's kind of funky. Hopefully this gives you some guidelines, some intuition on how to figure that one out. The rest of them, the rest of the problems might vary in difficulty, but they are at least, the uh, standard problem where they just give you some curves and ask you to find the volume by cylindrical shells. So they're not phrased strangely. So I'll let you attempt the rest of those on your own. Let me know if you guys need more examples. Since I skipped the examples in the book this time and went straight to the homework, maybe you're not satisfied with that. Let me know, and I'll take it from there.